Hello and welcome to this Zen WorkForce presentation. We're going to review our new product design. This is going to be a process where we go through many of the steps of what it takes to make the product and how it would be implemented, and there'll be a little bit of education about machine learning along the way. So let me discuss the agenda in a little bit more detail. Hopefully that will clarify things. Here's our agenda. We're going to start off with a discussion of what our product goals are in terms of features. Then we're going to go into a discussion of what we're trying to accomplish while designing the product to create those features. And then we're going to talk about the design process itself, like in what order it goes and whatnot. We'll also talk about the development process, what's involved in moving from one stage to the next stage and how quickly and whatnot. And then we'll discuss the database and go over and do an overview of what's involved with the database itself and how it might look visually and structured. From that point, we're going to get into a little bit of detail about the database structure, but we'll do it in such a way that you have examples so that it's easy to understand how this thing is laid out and what it really means in terms of features and in terms of the user interface, which is what we really care about conveying in this video. So that will be a very important component. Then we're going to define what insights are, with examples of a user screen that might convey an insight from our system to a user. We'll talk about how graphs and charts fit in and why they're important. And we will have a high-level discussion of machine learning and how it applies to our company, Zen WorkForce. The machine learning discussion is unavoidable, but it's not that painful. So we'll see how everything applies, ways that we have to transform data to make all this happen, and manipulate the system in such a way to make it more flexible and handle more types of data and compute a wider variety of insights. We're going to review the algorithm that computes those insights. Don't worry, it won't be in that much detail. It'll just sort of outline generally what it's doing. And it'll kind of refer back to some of the discussion that we had prior to that on these slides, where it'll all kind of tie together. We're going to review the user setup with examples of the user screen. So what the user experience is, or the administrator's experience is while setting this thing up, how difficult it is, what does it look like, what do we, what goes where, that type of thing. We're going to show that and have some visuals for you. We're going to do an overview of some of the tools that are used in machine learning and how to set this up in an automated way, and some of the considerations that pertain to implementing this algorithm in terms of cost or product decisions or tools. So we'll get into just a very little bit of that just to give a flavor for it. And then we'll discuss some product concerns and close out the discussion. And with that said, we'll move into discussing our product goals. So we have some pretty ambitious product goals when we're talking about our analytics here. Let's start off by saying what we want to do is we want to capture and store any information that describes an almost limitless number of people, places, or things. So that's a pretty flexible base to start from, right? Then we want to capture information that describes any event related to those people, places, or things. Now we have these two things, and what we want to do is automatically provide naturally stated and clear, actionable insights to the user with very little setup, meaning no time and expense of hiring a statistical analyst and all of that. So let's talk about what that entails. The system to generate those insights would have to identify if any of the people, places, or things are determined by an event. So is 1 determining the event, 1 determining number 2 above. And let's go on to the next one. The system should identify if the people, places, or things in number 1 are determining other people, places, and things. The system in number 2 should determine if any of those events are determining other events. So these correlations, when they're found by the system, should be used by the system to automatically predict the probability of one of these items based upon the other of these items. So that's really what the goal is here. The system should take that predictive insight and apply it to the activity in the system to identify which events are likely to occur in the future. Because if you look at number 4, what we're saying there is we're looking for these correlations between these things. But once you find the correlations, we want the system to actually do something with it. We want it to take these predictive insights and apply it to what's going on in real time being captured on those tiles. And that's the value of applying the statistics. So not only will it tell you what the insight is, but it'll tell you what it means in your world. So in addition to doing all this with the data in this system, we're going to allow for the import and integration with other systems and data sets. So everything kind of above was talking about the data that we have within our system. But if we want to expand our universe to handling even more, then we want to integrate with other third-party systems, or maybe just pull in a third-party data set. Let's put that up there. And that type of integration goes a very long way. We could even use our system as a black box or a system that somebody could plug into with theirs, and they could market this or white label it or do anything that they want to achieve the, to do it within their universe rather than having to come into our product and do it. So there's a lot of different ways that we could market this, and you can see we have some pretty ambitious goals. And basically, we want to do just about everything in the world and do it easily. So the key here is insights are found. They're not just computed based upon telling the computer what items should be checked. So we're trying to determine if there is an insight, and this is a major differentiator. Others are presupposing what they need to check. And you may not check something that would have provided a valuable insight. The same limitation applies when you're looking at the data and what the user can define as a predictor. We don't want to limit that either. Just let them do whatever they want to do. So this is not a traditional system where the screens containing fields that you're limited to are there out of the box. This is totally a user-definable experience. What you want to predict, what you want to predict with. You don't even have to know what the relationships are between anything. It'll find them and return it to you. So that's the essence of what we're trying to achieve within our product goals. So let's talk about some of our design goals here. So because these design decisions drive the capability, flexibility, and ease of development. Everything flows from design. And the main concern here in design is automation. So we want this thing to operate unattended. We want the computer to dig through all the data, find the correlations, and make predictions without the user, being involved or our staff being involved. So typically in machine learning, there's this process where people work with these elaborate sets of tools in these workbenches, and they try to make things very accurate. And they could spend years and years, but it's the key that I'm trying to make here is that it's a manual process. And our goal is to avoid that manual process and the need for all of those tools. And at the same time, we're willing to accept that it may impact our accuracy a bit, but we're willing to accept that trade off. Now, to accomplish this, we need to identify all the information in the system in a way that the system will know where to plug each pieces of those information into a formula like a regression or whatever type of statistical analysis that you're using in the proper way. So again, the data structure is the driving force in our design. So with that data structure, we'll also select specific statistical approaches. These approaches will require the least manual intervention. They also will need to work with our type of data and compute their level of accuracy, like self-examine themselves as a feedback loop, so that if it does compute something that is kind of out there and doesn't apply or is not valid, then we can kind of throw that off to the side and move on to the next option to compute. So these insights and how we compute them are all driven at the design level. And that's a key takeaway from design goals. Next, I'll talk about the design process in a more broad way. Okay, let's talk a little bit about the design process, how it flows, and what's involved in designing the software. What order we go about doing things. And it all starts with the general data structure. Everything flows from the general data structure. So the general data structure kind of dictates what screens and reports are even possible, because you can't have a screen or report unless it's really displaying what is in the data structure itself. So the data structure is definitely driving. That's kind of why I have everything flowing downhill here. The ability to make the user interface. So once this is done, this data structure, it kind of dictates and it kind of flows naturally, making the screens. So let's look. Then the next thing is, once you have the screens, you kind of have even more specific tables and fields and queries and code that are dictated, because if you want to do something on the screen, well, might have to write a query or something to do that. So once this is all in place, then there are times when we have minor revisions, and it won't typically impact the broader data structure. However, it would usually involve some screen changes and specific tables, fields, or queries or codes to be revised. This would be considered a minor user interface. You find this often with A/B testing. And then there are times when there is a change in direction in the company in terms of their whole product. That is a little bit, I guess, more serious. And at that point, we're forced to go back to the original premises and underpinnings, the foundation of the pyramid itself, change some of that. And that's what you typically try to avoid in design. And if you do make those changes, then there'll be a pretty much of a cascading downhill impact to the screens, and then, of course, other code that might be impacted. So our general design process is where we are now, starting with this broad data structure and focusing a lot on that in this presentation, knowing that it will drive the screens that need to be made from it. What our goals and the data that we're capturing is going to drive the screens. They'll almost come to us naturally, and then the screens will have different fields and buttons and actions and reports that are going to kind of dictate the kind of queries. So there's kind of a Zen to our Zen workforce and the design process in general that we've adopted here. So let's just briefly cover our software development process. Like, how will we actually work on a daily basis? And the process that we will employ is one known as Scrum. And Scrum is an agile software development process. And it's known for team working with short sprints, as they're known, to deliver your objective with the goal of adapting to changing requirements. So you're trying not to wait a very long time until the very end to ship a complete product. You're trying to release it in small bits and pieces along the way and what that does is if the client gets these small pieces along the way and wants to, you know, sees it and all of a sudden thinks something different, wants to change direction, it's not going to be as impactful as creating the whole product, scrapping it, and then moving forward. And it's always good for people to see some progress along the way with these sprints, bringing new features out rather than waiting forever to see a complete product. So this process is sort of known as Scrum. It's one of the agile software development processes that's kind of popular these days. So I want to talk briefly about databases, since that's where all of our information is going to be. In this scenario, we have our app, and it's a data entry app. And it needs to store information in a production database. Of course, that makes a lot of sense. Then you probably want to separate your production database from your data warehouse. So, why a data warehouse? Well, a data warehouse is a separate place that is used typically for your reporting and analytics to keep it separate because there are a lot of heavy demands upon this, I guess you could call it a copy of your database. And you don't want that to affect the performance of the data entry in your main production database. So this is a typical approach. But in addition to being a copy, it's not an exact copy. What it does is it's a copy that's slightly transformed into a format that is a little bit more usable for reporting purposes. The way you store data is not always in the best format to use to be consumed by reports and analytics. So an example of a data transformation would be converting something like date hired to the number of days employed. Number of days employed would have much more meaning in computing a relationship between, the date that you've been hired and the date that you had a promotion. So the number of days is more important. The date itself doesn't have as much meaning in that context. So some of these transformations are really valuable when we're trying to gain insights, when we're doing our calculations to come up with our analytics. So that's sort of why the two-piece to duplicate database approach is often used. And many people are aware of this. I just thought that I would take the time to give a little explanation of it and that we would most likely be employing that. So now we're at the heart of the presentation, which involves the discussion about the exact structure that will accomplish all these miraculous things. And this is going to be a high-level representation with examples, as you can see. When designing the database structure, we want a structure that would accommodate almost anything a user would want. So this database must be high level and non-specific. The structure should allow the user to find almost any type of information and capture it and store it in some way. The structure should allow the code which calculates the insights to know what information plugs in where. So there has to be some idea of the type of information that the algorithm needs and where the algorithm should look to grab it. And we're going to get into that a little bit so that it's understandable, because it does have a lot to do with driving the product's design and user features. So with that said, let's kind of jump in a little bit and discuss the one of the topics here. So we have the structure. This is the labels that are the name of the person, place, thing, or event. We kind of had a little bit of this structure, although we didn't totally leverage it at the very beginning. It was 3 levels, so we're going to kind of stick with that for this presentation. And I'm going to give examples. But the key here is that there's a 3-level structure, and we can expand it to work in the universe of HR, which is people, or we could also expand into different universes like events and other things. And I'm going to give you right now a couple of examples of how that might look. So let's show one. We were kind of used to this whole multi-level tier thing in HR, where there's a vice president, a junior vice president, or now we have a director, a department manager, employee. The key is, in the realm of people, this is an example of 3 layers. If you're talking about something like an event, then you have something more like a concert series, then a group within the series, and then maybe the individual concert. And then you drop down a little bit further and you're talking about a hotel district. It's the group within the district, and then the hotel within that group. Now, this is the structure, not to be confused with the actual name of, say, the employee, which is John Smith. But John Smith needs to go somewhere, so he needs to go in the structure under the word, I guess, employee. And again, this is something that we're already comfortable with. Now let's start talking about additional pieces of the puzzle. So we have these descriptors of a person, place, or thing, things that describe that person. Could be a test score or whatnot. And these descriptors are used to predict something. So let's talk about that. They're usually, in our scenario, used to predict some type of observation. And these observations are gathered in real time on the tiles. So we have these predictors, which are properties of the person, place, or thing that we're using to predict an event or an observation that is also related to the person, place, or thing. So let's elaborate even further so that you can see how that might look. And you might notice that we are color coding here, so it's easier to understand. On the predictor side, we have things that describe, in this case, the blue scenario, which is the employee, their date of birth, their hire date, test scores, and their personality and whatnot. Also, we have events that we're capturing in the tile, and these tiles might talk about their bad dress quality or crazy things that they safety infraction, running with scissors, whatever it might be. These are captured on the tiles, and again, these blue things are also events that relate to the employee. Let's follow this example further into our events, and we're talking about an individual concert, and the place that this individual concert is basically the type of venue. So this individual concert has a venue type. Maybe there's 50 concession stands at this concert. Maybe there's actually a bunch of different entertainers, and maybe the food quality is not so great, or it is great. And the entertainment has a risk factor associated with it. Maybe it's the craziest metal band where everybody is crowd surfing, and that we give it a high risk factor. And then we look at other things that are associated with this concert, which are the events that happen at the concert. There could be damage, or somebody can complain that the food was horrible. Attendees can complain about a variety of things, or attendees can even be violent, or anything else that is a observation at a concert. But again, these are all either describing the concert or events or observations that happened at the concert. Let's follow the reasoning one more level down. And we're talking about maybe an individual hotel audit here. And in this example, we have square feet, lodging, and the year this hotel was built. These are all properties or descriptors, again, of the individual hotel. Again, events that could be observed at this hotel might be a broken sign or some stained carpet, or maybe the staff going postal and doing something that they shouldn't be doing. And that again is the individual hotel. All these things relate to the individual hotel. So we're pretty flexible, I think we'd all agree here, right? We we actually now have a structure that could handle almost any type of person, place, or thing, and have the user define an unlimitless number of descriptors or properties about those person, places, or things, and can capture any number of events surrounding those people, places, and things. Let's continue on and talk about the fact that all of this information that we've been discussing so far originates in our system. So it was either entered in as a test score, or maybe we imported it in at some point, but the tiles are clicked, they're all stored in our system. But what if we want to work with other companies, third-party systems? Because that'll make us way more marketable and more flexible. Let's tie into a manufacturing system in this place. And in this case, we're talking about the worker productivity and worker defects. Those are things that are observed that plug in just like a employee safety infraction, but instead of us typing them in, they're coming in from maybe a production system, and they would behave the same way when they're consumed into our system. Let's give a couple more examples to drive the point home of other companies' systems that we could, leverage and pull information from. So an attendance system. There are companies out there that track missed days and late days, and maybe other things that are related to the person's attendance, and we could bring that in, and just in place of us entering it in this system, it could come in from a separate attendance system. Let's do a third one. So we also have maybe a customer survey system, a third-party system, where maybe in the hotel in this scenario, they're looking at a customer survey and they say, wow, the staff were nasty. Well, we could tie that back into this hotel, and it's coming from a third-party system. So most of these things that you're seeing here are related to, they're basically observations and events that we're importing. But what if you want to import something that describes a person? Let's talk about a learning system that has test scores. If we tie that information in, then we would, either import it or link to it as a descriptor rather than an observation. But again, this is just illustrating the flexibility that we have within the system to do a variety of things. So how do we gain insights from all the data that's stored, and what are insights? Well, let's look at this diagram in a different light. So insights are correlations between predictors and observations. So here we're going to look at something like promotion date and see that maybe the promotion date was predicting that employee might be really stellar and go above and beyond with a customer, doing customer service. Or maybe the test score that this person got wasn't so great and it might indicate a safety infraction. Or maybe their personality kind of indicated that they would be coming in with baggy pants falling down to their knees. Or maybe the number of concessions was too much for folks to handle, and it pretty much is a good predictor of a food complaint occurring in the future. So I guess you could kind of see how these are working. That crazy rock band is going to maybe lead to some attendee violence. Maybe when we have a certain risk index, we can predict the likelihood of a future attendee violent act at the concert. And maybe big places, big hotels, just inevitable that you're going to have a dirty floor, or old buildings will have stained carpets. These are all just examples of how the predictions work. You have to have a predictor predicting something else. So this is a pretty flexible and advanced way to look at things. We'd agree that this is pretty flexible so far, right? But we want even more flexibility. So, for example, does a test score predict promotion date? Let's look at this for a second. Both are on the same side. There's nothing on the to be predicted side. And does bad dress predict a safety infraction like an oil spill? Again, both are on the same side. In this case, we have no predictors to use to compute this. So, finding these additional insights the way we have been approaching this on the last slide is not possible. To solve these examples, we need to treat the promotion date as a tile to be predicted, and bad dress as a predictor, essentially moving each to the opposite side. Well, that would certainly create a whole heck of a lot of flexibility. And the good news is I found a way to add that option in the setup to do just that, as you'll see in some coming slides. So, wow, we're really making something pretty amazing. So let's keep your attention and we'll keep moving on. We have all these insights that we're pointing out here, but how would these look to a user? What does the user see in their screen? How do we convey that knowledge? Let's take a quick peek there. So here we go. So we're going to revisit this and we're going to see that what the user would see, and believe me, this won't be what the screen looks like, but it does kind of contain the information. It may be not the most gracious looking format, but it does kind of say that, hey, you remember that skills test? It really is correlated to a safety infraction. Again, the predictor and the to be predicted, the tile. And it did predict with a pretty darn strong correlation. So it seems like this is something that is an insight that you should pay attention to. So it keeps going down, and I have them sorted by how strong the correlation is, and they tie into what you saw in the previous slides to help illustrate. In case you want to rewind and look back, you can kind of see how those previous slides with the same examples tie into this one. Another thing you might notice here is I have insights computed on. This is, if you refer back to the other slide talking about the database for the data warehouse where we were going to run against the separate copy and compute things. What this is doing is we're running against this database and trying a whole heck of a lot of different combinations to come up with these insights, and we're going to date them. So this would actually be a drop-down box where they could go and look at what what did these insights look like on the 12th? Go back maybe. What did they look like back at the beginning of the month? How are these things changing? That might have value to a user. The most important thing to point out here is that this is a very high level actionable screen. It's really related to the personality type of the user. So if the personality type of the user is like, okay, I get it, this points me in the direction, I could take it from here. Then you have some of the users who might be a little bit more analytical and want to know a little bit behind why that is a correlation. Um, they might not want to have to compute it for sure, but they might want to know a little bit more. So we have this details button that we can press. So let's click that details button and see what it'll tell the user. So it pops up another screen or a subscreen, and it basically tells them that we can predict the future probability of a safety infraction with a simple formula. Why is this important? A, because of the person's personality type, but B, I could imagine somebody walking into a meeting and just, not showing off, but want to show that there's some real science behind what they had and said, listen, I could tell you if I take their test score and multiply it by whatever, that person is probably going to be a safety risk. And you're walking to a meeting, and before that, you were kind of talking about gut and feel, and now you're talking about not only that you have a safety test, but that you know that the safety test has meaning within your organization to predict uh, safety infractions. So that could have a pretty good use in the realm of marketing when you're trying to empower people with information. And we go on to say that the statistic is not arbitrary and by chance, and that this statistic kind of explains a good portion of the variance that you see around the line. I even have an illustration where it shows all of the variances around the line. So would somebody want to use this? Again, maybe, maybe not, but it kind of makes the product look like it's rather professional even if they don't use it, and it kind of, if we're trying to understand why it came up with something, at least we could explain to the user when they're trying to troubleshoot why did I get this prediction. We can kind of come in and support them and say, well, look at the details screen and let me help you with this. Another thing that it could do, maybe if you're a little less adventurous and you just want to get right to the USA Today version, is you could click the Find Risk button. And this is going to be pretty interesting. So what the Find Risk button will do is it'll look in your database and say, if I plug that probability formula into John Doe, based on his test score, he's got a 70% chance that he's going to have a safety infraction. We better, maybe bring him in for a little bit more help or do something more proactive with this guy in terms of the management of our company to save money and time and risk and quality problems in the future. So that is basically the value of the insights and predictions that a user gets when they look at our system. So one form of output from our system are these insights and predictions that we've just reviewed. And in addition, we could get charts and graphs from our system. So let's do just a brief discussion of what the issues are over there. When we use charts and graphs, we're going to be using charting controls like infragistics to visualize these trends and relationships. And we're going to keep those charts in the web interface because of development speed, cost concerns, and the bigger screens definitely more usable with these graphs and charts to make them more understandable and easier to manipulate. The mobile app will be more limited to data entry and those types of functions to keep the cost down there as well. So that's a little bit about the graphs and charts. But these controls, like the charts themselves will be user definable. So the user should be able to, say, drag and drop from a list of their predictors and tiles to be predicted, and kind of move them around on each axis of the chart, and they'd be user definable. Beyond that, all the settings that they do to set up their chart, they could save them and recall them later, which is a pretty useful feature. So insights are powerful, but some relationships are not easy to understand in that way. So a graph is actually visually showing you more data than a single insight can. So they have a value in that regard. In addition, when starting the client, there's enough information in the system. So at an early stage in using the system, the charts are going to be where the user activity is centered. And then later, as there's enough data to work with it, they could start relying upon the insights, because the insights are going to kind of show that this insight is not valuable because it's just no correlation, or it's not significant because we don't have enough data, and it could have maybe have been by chance. So then if they don't have that, then they're probably early on in the process, and they are probably going to be relying on graphs and charts at that point. And the graphs should not be underestimated. They, in many times, can explain things that you would not otherwise see, such as when information isn't linear. The graph on the screen is clearly linear, but I could give you an example to explain when something is nonlinear. An example of a nonlinear relationship is, say for example, the distance a person walks relative to their age. Well, babies don't walk. That makes sense. Kind of a low age and kind of little walking, and then you get older and you start to work more. That's still kind of linear, right? Well, then wait a minute. Then as you get a little bit older, it sort of levels out. And just because you're older doesn't necessarily mean you walk more or less at a certain point. And then it takes a turn. And then when you get much older, you actually start to walk less, if at all. So that shape is not a straight line like you see on the screen. It's more like a U shape. And that is not linear. And the problem with data that is not linear is that regression will not work in a very automated fashion, which is what we're trying to accomplish. So in some of those scenarios, a graph would be better than an insight. So I just wanted to kind of throw that out there so that there'd be a little bit of an explanation surrounding graphs and charts being a little more valuable than one might think, and people kind of connect with them, which is a great thing. So we've defined our goals, what we want to compute, what we want our screens to look like for the users, what insights they provide. But now that we've defined our goals, we got to discuss how we're going to get there. So there's confusion everywhere. And within our organization concerning machine learning techniques, its different applications, the different tools, and how they may apply to our organization. And none of this confusion is helped by marketers who distort the names of the technologies and misrepresent or hide the tech that they actually use. So here I'll give a broad overview of machine learning, so it'll be clear what applies to us and why. Hopefully this will be informative, redirecting and expanding what you have understood up to this point. As participants in a machine learning company, we do have to dig in a little. This will be very high level and mostly accurate, but not totally, due to some oversimplification that we have to employ. In the end, you will see how the knowledge impacts the product features, their implementation, and the overall user experience. So let's start with a discussion of supervised learning. Supervised learning deals with labeled data. This is data where we understand what is what because it's named. And we also know what we're checking for. So, an example of supervised learning would be how strong the relationship is between an entertainer's risk rating and attendee violence. All this labels data. So, I'm sorry, all this data is labeled. So it has a meaning and we know what we want to test. So this can be somewhat automated. And that is what we're talking about when we're talking about supervised learning. That is a pretty good area. Now, unsupervised learning, I hear a lot of people talking about, and unsupervised learning is really not what people think it's about. It's about categorizing clusters of unlabeled data. So, for example, a bunch of unlabeled animal images, and we want to classify the images into groups that seem similar. We know there's a relationship, but we don't know why. The groups are not labeled, that are produced when they're classified into these categories. So typically, you hear this discussed as the black box in statistics. Your model will group future images with some accuracy, but again, you might not be sure why. That's where they get the name black box. Maybe it's grouping animals with 4 legs together, or by color, or something else. But this is also typically a hands-on approach that is less automated. So, unsupervised learning, again, is about taking unlabeled data and categorizing it. It's not typically what people think it is. Reinforcement learning is kind of in the area of artificial intelligence. What that's doing is it's looking at decisions captured along the way to an outcome, say a tile, and attempts to find the best path to obtain the desired outcome. Like if the tile says something good happens, we wouldn't want to capture all the steps and decisions that that person made that caused him to do that positive thing. Um, so for an example in this, you would probably make an algorithm of a car, and all the sensors that the car had, we would look at every one of the sensors and what they detected along the way before they either crashed or did not crash. That's your outcome. And then it would go back and look at it. It's really successful in tic-tac-toe. So all the steps that you made in your tic-tac-toe game, we're going to capture all those steps, and what we're going to do after we capture all those steps and see what the outcome is. We're going to look at this millions of times, and then we're going to figure out what steps in what order produce the outcome that we want. And that's what is meant by reinforcement learning, which is the third general domain of machine learning. Okay, so let's talk about us for a second. So we're lucky enough to be building a database and establishing processes and procedures with labeled data. Our data is labeled very well. So many of the concerns surrounding unsupervised learning don't really apply to us as much because we're not looking to categorize things and so that we can give them labels, because we kind of already are starting with labeled data. So then that leaves us with reinforcement learning, which also doesn't apply to our company because we don't capture any data about the decision processes that lead up to any outcome. Or basically, we don't know all the steps that went into a person causing that tile to be selected. If that tile is a safety infraction, we don't know every single thing they did along the way that led up to that safety infraction because we don't capture it. So again, reinforcement learning doesn't apply to us, and unsupervised learning does not apply to us for the most part. Let's think about that a little bit more. Unsupervised learning could come into play in the future if we try to create insights using data that doesn't have a common meaning across organizations, which we have discussed at great length. So in that case, the data labels aren't very useful, right? Because uh, what one thing means to one company, even if it has the same name in another company, might not have the same meaning. So therefore, the labels don't have as much meaning, And if I want to find a commonality across multiple organizations, I might use some form of unsupervised learning to make sure that we're talking apples to apples before trying to apply some of our supervised learning techniques. Now, I'm kind of going out there a little bit with this example, but for the most part, I think we could all agree and understand that supervised learning is sort of the domain for Zen WorkForce and where we would want to focus our attention. So, as we focus in on supervised machine learning, we're going to realize that it's going to be grouped into two general categories, two different types of problems that we're trying to solve: regression and classification problems. So, let's talk about classification problems. And a classification problem, the name might cause a little bit of confusion, but let's talk about what it is first. Because classification is not supposed to be a supervised machine learning type of thing. It's supposed to be unsupervised, as we just talked about in the previous slide. But classification in this regard is a problem where the tile, the value of the tile, is a discrete category, which is, for example, male. You're either male or you're not. Red. You're either red or you're not. Or bad dress, either bad dress or not. You either click the tile or you didn't click the tile. It's sort of a binary thing. That's what we mean by discrete when we're talking about a classification problem. But the second option is regression. And regression is interesting. So a regression problem is when the tile is a real value, such as if the tile represented the number of dollars, or there was a weight associated with the tile in terms of importance or severity. So those are our two main forms of machine supervised learning: classification and regression. Remember, in the case of classification in supervised learning, it differs from classification in unsupervised learning since your supervised data is already labeled. So we're not trying to classify our data into groups that we could label. We are simply saying our predictor is already a classification rather than a number. And we have to work with that differently, knowing that. So I hope that clarification helped. But the two items that you see bolded here are discrete and continuous. So that is important concepts that drive our product design. And the algorithms that are required are dictated by this fact that your tiles or what you're trying to predict is discrete or continuous. So discrete data, again, is a yes or no. It's a true or false. These stay late. Somebody stayed late, yes or no. It's either true or it's not. And a continuous data is usually a number within a range, and the value has a meaning to another, to like a greater value or a lesser value. So 10 might not have a lot of meaning, but 10 relative to 12 or 10 relative to 20, it has meaning because it is along a continuum. So a continuous data is a very important concept to have in this whole thing. So where does Zen WorkForce fit in with this? Because if you look at our tiles at first glance, you press a tile or you don't. It's, raise your hand. I think your answer would be definitely classification. This is definitely discrete data. The tile is either pressed or it's not pressed, right? But let's look at some examples to test that assumption. And this won't be an exercise in academics. It's a serious product design consideration that we have to look at when we're talking about our tiles and the features that we want them to have. So at this point in our story, we believe that we have a classification type of an approach within supervised machine learning that we need to do. Is that true? Is that not true? Let's see what happens next. Okay, so let's get into a little bit of, what a tile really is. And, what type of data is that tile? Our dependent variable, we have to kind of know what it is. So let's go through a few examples, okay? And in example one, we're going to say that the tile is something simple such as I stayed late. Well, if you click that tile and there's no other configuration or modification of that tile, I think we could all assume that this is true or false, or what you would call discrete, binary. So let's use that as example one. Example two, let's add a feature to allow the user to assign a default number. Let's say that tile stayed late. We're going to assign it a default value of 8, which is to indicate the extent of the lateness, which in this case would probably be pretty darn late if we gave it an 8. I guess you could always override that value with proper permission in the mobile app when you're selecting it, and that could be a design consideration that we talk about as we move forward. But ignoring that tangent, I guess, the point is to illustrate that we are now not dealing with a discrete true or false, but we're dealing with a continuous number, 8. So now we have the exact opposite example for our tile. Let's give a third example. Let's assume that we're not using our tiles, but we're getting our data from like another system, like an attendance system. And we're bringing in the number of days late or absent. Again, we're not dealing with a true or false binary discrete number. We're dealing with a continuous number, the number of days late or absent. So there we go. There's our example 3. Again, doesn't seem like we're dealing with anything true or false in those scenarios. So I guess what we should conclude is that we're going to have to deal with both of these types of data. And our data does dictate the tools and the computations that we need to determine these correlations and insights, and further predict future events, which is one of the key things that I showed you previously on a different screen. So now we can assume we need to identify and apply the proper statistical computations for both of these types of data. Okay? I would like to point out that there is this other method called batching, and it's kind of a workaround. So instead of one tile with a number, you could create 3 tiles for bad dress. So this would actually work around having to have numbers and stick with continuous. You can make 3 tiles that would always be yes or no when clicked. For example, bad dress, mild, bad dress, moderate, bad dress, extreme. So now you have 3 different tiles that could either only be on or off. So I've taken a problem and worked around it by making 3 tiles. So I've converted a number to a yes/no, a discrete value of data. So one of those tiles is either clicked or it's not. But this does add another step to the setup. So that's a little bit more work to set up. I don't know if the user would like having 3 tiles instead of one that they could click and pick a number. And I guess the advantage is we'd be sparing ourselves identifying and applying the proper, having to pick between these 2 statistical functions, one that handles true and false and one that handles numbers. But by the same time, we'd lose the flexibility by exchanging this numeric data for a discrete piece of data, because numeric continuous data at times is more descriptive than just yes or no. A number lets me know, safety infraction, yes, no. Or safety infraction of a 9 is quite different than a safety infraction of a 1. So all of these things go into defining the types of data that we want to work with. And it seems like, as a conclusion from this screen that we're and this discussion that we're having, that we just need to be able to handle both types of data. So that means that we have to maybe dig in and start looking at the types of regression that would handle these situations in coming screens, right? Regression seems like a solution to what we want to do. As a good candidate for automation, we know where we plug what into it, and it can provide feedback in terms of accuracy to know if we have a real insight. So let's dig into regression a little bit more to see how this might fit all those circumstances that we just discussed. We want to be able to handle discrete information or numbers of continuous information, and we want to be able to do predictions, and we'd like it to be automated, which is what regression is capable of doing. But there are a few flavors of regression, so let's talk about just a few of them. Okay? So, as you can see, regression is a supervised learning tool, and we can use it to compute insights and predict things. So, we covered in the previous slide the regression concepts of independent and dependent variables, what we want to predict, and predictors, as well as our goal to determine correlations and connections between the two. So, for regression, we're going to start off with linear regression. And what linear regression does is it determines if the tile, which is the dependent variable, depends upon a single independent variable or a predictor. Okay? So, for example, does the number of safety infractions depend upon the personality, such as like an aggressive index of that person? So, again, this is an example. Linear regression is an example of regression that works with a continuous and only one continuous dependent variable. Okay? That's a very key thing to take away. So the tile has to be a continuous value. Okay? Let's move on to the next one. Multiple regression is the same thing, except here what we're trying to determine is if the tile, which is a dependent variable, depends upon several different independent variables, which are predictors. So, for example, does the number of safety infractions depend upon a combination of aggressiveness index, age, and number of references? And if so, what role does each play? So that would be an example of a multiple regression analysis. The lasso regression analysis is pretty similar to the multiple regression, except it looks at all these things and just tosses out the ones that don't really have any impact predicting. And they really don't play a role. So it's a very similar thing, except it works in a way that just eliminates what we don't care to look at. Logistic regression is going to be a main focus for us because this is similar to multiple regression, except the dependent variable, the tile, remember, was the problem, isn't a number like most of what you see above, but rather it is like binary, discrete, yes or no. So, for example, does a credit score predict the outcome or approval of a loan? That would be the outcome or approval of a loan is yay or nay. You either got it or you didn't, so it's binary. So this is an example of logistic probability, and it directly computes odds and not probability, but we can convert it to a probability. So these are the forms that we have to consider. that we have to use under different scenarios based upon the data that we have available to us. And that is basically the main gist of the algorithm that we're going to be looking at. So the algorithm is going to say, hey, I'm in this circumstance. I need to use this formula because it is this circumstance that's clearly outlined on this slide, and I'm going to have to apply it. So one of the last things to take away from this is that all forms of regression expect continuous value for the independent variable, which is the predictor. So you can't have the predictor as a yes, as a just yes or no. It has to be basically a number. Okay, so let's go into other discussions and see how this plays out. So when we spoke about regression, we did point out one of the main important requirements is that all forms of regression expect a continuous value for the predictor, the independent variable. So if that is a requirement, we have to make sure that all of our data is like that. So we did discuss how to use different types of regression to address continuous and discrete variables that were the dependent variables, as well as multiple predictors. But how do we perform regression when we have discrete predictors, independent variables like male or female? Again, regression does not like binary input. It is looking for continuous numeric values. Male and female is not. What about the disc personality profiles? If you remember, the disc personality profiles could be a great predictor of things. So those independent variables, there would be, you'd either be D, I, S, or C, which is dominant, influential, compliant, or steady. But again, those aren't continuous numbers. So we need to convert those discrete values, like male or dominant, to the number 1 or 0. So at least it will be a number. So let's think about doing that for a minute. So we have male or female. All we would do in the case of male or female is create a dummy variable called isFemale. So if its isFemale was true, it would be equal to 1. If it was false, it would be equal to 0. So we're just representing male or female with a 1 or a 0. So now we've just made regression happy. Let's talk about the disc personality profile. In that case, you'd create 3 dummy variables. Is dominant? Yes or no. Is influential? Yes or no. Is compliant? Well, yes or no again. So if any of those are yes, they're equal to 1, and that is equal to that personality type. Pretty clear. If all of them are equal to 0, then the personality type must be is steady, because if dominant, influential, and compliant are true, then steady must be true. And only one can be, of those 3, dominant, influential, and compliant, can be true at any time. So, in practice, when the user is setting up their predictors, we would just simply create these predictors instead of, you create isFemale instead of a predictor called sex. Or you create 3 predictors for dominant, influential, and compliant instead of creating a predictor called personality type. So I think now you're seeing how all of this design and what type of algorithm you use does dictate how the system is used and how you would help somebody set the system up. You might remember earlier that we were talking about data transformations. We were talking about, well, we have the hire date, but what we really want to look at is the length of employment. So that would be an example of a transformation. So the length of employment impacts something like safety infractions. You can't just say, I was hired on June 14th. How does that impact a safety infraction? Hire date isn't as useful. So again, we want to convert hire date to length of employment. So what we're going to do is basically have a formula to do that. Length of employment is the current date minus the hire date. And in practice, at this point, we're going to just have what amounts to a checkbox in the setup so that you can convert a date to basically the current date minus whatever date you typed in, hire date, fire date, promotion date. We're going to have a checkbox that just allows you to convert it right in the setup. Now, that is kind of limited because we're only talking about a date and only being able to convert a date to the hire date. So as we get into this, if we need to do more extensive type of data transformations, we'll probably create a user interface to do that, where you could create formulas like the formula you see on the screen now, but you could create a whole bunch of them for whatever your purposes might be. Anyway, I just wanted to go over that one bit and kind of return back and revisit what we were talking about with data transformations and in design how we would address it. Next, what we'll do is we'll actually look at the algorithm. So that accomplishes all that we discussed based upon the regression formulas and getting data and how it will pull all of that in and compute the insights. So let's look at that next. We know a few different forms of regression that are a good fit for Zen WorkForce, but how do we apply them? So here's the algorithm that applies them. And what we basically have is a loop that goes through, selects all the different combinations of the companies that are set up in our system, our clients, and then looks individually at each of their dependent and independent variables, determines if the dependent or independent variable is binary or not, and then applies either a logistic or a linear regression. So this should tie together everything that you've seen in all the prior slides. So we've narrowed it down to the supervised learning with these different types of regression algorithms that would need to be applied in different circumstances depending upon whether we have a discrete or continuous type of variable that we need to compute. So this basically is an illustration of how we would loop through each tile and predictor to compute the correlation for the prediction line for every combination. This is only meant to be a high-level example. This example is for a single regression, not a multiple regression. More, so we're not looking at looping through a lot of different variables that we could use as predictors. We're only kind of looking at one that would either be continuous or discrete. And that's just so that this example could be a little easier to understand and digest. It's not meant to throw anybody off, but it's just meant to show how we make the sausage here. Okay, let's move on to talking more in the here and now about the screens and how you would set this stuff up to be used if you were the administrator at one of our clients, or if you're Zen WorkForce staff and you're trying to help people plug all this stuff and set all this stuff into our system. What would that look like? Let's look into that next. Finally, we get to see how all of this is set up. We have to set up our predictors, and we also have to set up our dependent variables that are being predicted. So this is a conceptual view of what a setup screen would look like. We'd have, as in our HR example, a name sort of like hire date. And remember the three levels that we had. You might have had division, department, and then employee. That is what we're referring to in this second box where you see employee. So this predictor is something that is basically describing an employee. Remember, these predictors are also a synonym we used was descriptor. So hire date describes employee, which was the third level down in our example on the person, place, or thing example that we gave earlier. Hire date, the data type is a date. So that's pretty clear. You could also have a true or false or numeric value that you would like to set up here. So you could set up is male, here if you wanted. And that would be true or false. Or you could set up a test score here, and that would be more numeric. So if we're going to use this date to find insights in this scenario that we're looking at, remember the conversion that we're talking about to convert a specific date to a number of days? That's where that option I was telling you we put in here, we added that right here. So use this date to find insights. We would click yes here, and that would convert it to a number of days since hired, basically, rather than just the hired date, which would make more sense in analytics. And also, when you do this, what you're saying is not only do I want to use it in analytics, but if you hit no, then you can't use it in analytics. So what would it be used for? Well, it can only be used at that point to be a report selector, to limit data in a report. Show me everything with a hire date between this date and that date, and do my analytics and reporting based upon that range of dates. So if you hit no, you would only be able to do that. If you hit yes, you'd be able to do that, and you'd be able to predict insights about the number of days that this person has been employed. So that's an important piece to describe about this screen. The categories are the metadata that we use to classify or group the predictors more generally at a higher level. So that would be more useful when trying to make insights across different organizations. We'll get into that in a little bit more later, but I just wanted to show that that piece was in there as well. You'll also notice this no down here. Also predict this as. Let's talk about that next. So if you recall in a previous slide, we asked how could we predict promotion date using test scores? They were both on the same side of the fence, as you might recall. They were both basically predictors. So one of them had to become something that we wanted to predict. And that's where this last option comes in. So not only is it a predictor, but also predict it. So let's say we said that was equal to yes. In this case, we have filled in the value numeric. So it's possible to use the promotion date to predict other events and simultaneously predict the promotion date by just using this option here. And that's what we're showing. So when you do this, you're basically creating a virtual promotion date tile. So the insights can include the relationship between other predictors like test scores and promotion date So it becomes both a predictor, and which is an independent variable, and a dependent variable. So we have pushed it to the other side of the fence by doing this. When you push it to the other side of the fence, you have the option to select numeric or true or false. So if it's numeric, what we're predicting is the number of days to get promoted based, say, off of a test score, let's say. But if we set this to true or false, what we're saying is we want to predict if you will get promoted or not, which is true or false, based upon a test score. So one is numeric, so that is basically to predict the number of days to get promoted. And then if you were to switch it to uh, true or false, you're saying, well, what is the chance that you would get promoted or not promoted? So that is the main differentiator here. And it's important to note that adding this, creating this as a something to be predicted as well as a predictor will not automatically create a tile for it. It is more of a virtual tile. Just wanted to make that clarification. It's only used for to create insights because we had two things on the same side of the fence and we were trying to resolve that confusion. So let's talk about setting up the tiles now that we talked about setting up the predictors. Okay, so now that we have discussed setting up the predictors and actually making a predictor a tile, let's look at actually a virtual tile to be corrected there. Let's look at how we set up an actual tile, which is on the other side of the fence. So, here we go, and here is where you configure and set up your tiles. You'll notice that we have an observation, which is a tile, and we named it bad dress. And again, the level that we discussed on the previous slides is that this observation is related to the employee level, something that an action or an observation related to an employee. The data type here can be either true or false or numeric only. So those are your only two options for what we want to predict. Okay, so when a tile is selected, it would be true or false. You could select numeric as a default. So what you could do if you hit numeric, you have this extra option to select the default weight. Really bad dress might be, you might want to set it up as an 8. So we're going to call this like bad dress, and we want to, every time it's clicked, it would have the value of 8. Now we could have our mobile app that when you touch the tile, it would fill in 8, but maybe if you hold it down or do something different with the tile, double click, swipe it in a certain way, you'll be able to change that 8 to a 5 or whatever it is that you want to describe bad dress. So that's a pretty interesting way where you could capture the severity surrounding the observation, or in this case, the bad dress. If you were to come at it from the true false type of setup, you would obviously select true false in the data type instead of numeric. But you would probably name the observation bad dress medium, bad dress extreme, bad dress mild, something like that, and have 3 different tiles. So the advantage there, I think, would be it's easier just to click and not have to worry about it. But, as we discussed previously, there's more information in a number than there might be in just a simple yes or no. It's just more clarity surrounding what that is. Whenever a tile is reported, it is date stamped. And what we'd also want to point out, if we have a positive or negative observation. In this case, it's positive. I'd say bad dress is not positive, so I'd say that's false. So here we could also get into discussing what, is this plus or minus, negative, positive. I think we tried to get away from the word negative, but in this case, I just said, if is it positive or not? In this case, bad dress is not. So we can kind of do a different analytics, knowing that we're working with positive observations versus negative observations. You can kind of think of this as another form of metadata. So that's what we have discussed thus far on setting up a tile. And as you notice, again, here we have this option to also use this observation or tile, this thing that we're predicting, as a predictor. Similar to what you saw in the last example we did with predictors wanting to be tiles. How do we get something to the other side of the fence? So let's dig into that next. If you recall in a previous slide, we asked how could we predict a safety infraction like spilled oil using bad dress as a predictor. And I said I would show you how to do it, and let's get into looking at exactly how we would do that. So here you notice we've changed this option to yes, where it was previously no. And what we're saying there is we're defining observations and tiles, which means that this is something we want to predict. But how do we make it go to the other side of the fence to be something that we use as a predictor? So we use this option here. And now, if you think about it, when we select use as predictor, what we're saying, in addition to predicting if bad dress will occur, which is true or false, or how extreme the dress will be, which is numeric, in addition to being that type of predictor, we are also asking that the severity of the bad dress should also be used to predict other events and observations such as safety infractions like spilling oil or staying late. So this takes it from being a tile to making it become a predictor. And that is the key takeaway, is that we are making everything more flexible. The predictors are becoming tiles for the purpose of analytics, and the analytics are able to be used as predictors, meaning the tiles are able to be used as predictors as well. So it's two sides of the fence that we're bouncing back and forth between. So let's talk a little bit about the database that stores our predictors and our tiles. We have two areas or categories. There's free software and there's commercial software. And there's many databases that fit into either of these categories. The main point is that this is where all of your information is stored and retrieved. So MySQL is one of the more popular structured databases, and all these are sort of relational structured databases that I'm listing here for storing and retrieving information. And I'd say Microsoft SQL Server on the commercial side does well, DB2 very well, and there are some more expensive options there and some lesser expensive options there, such as FileMaker. And again, the point here is that this is where the information is stored. The language that most of those databases use to store and retrieve and manipulate their information is called SQL. It's a structured query language. And when you write that SQL code, you could use editors. And most of these editors cost almost nothing. So the fact that they're free or not in this scenario is not very impactful. Whichever one you move faster with is sort of the one that you should fly with. For me, I use the DevArt products, which just sort of I like that one better, how the product flows. But when you have all this data, you have to do something with it to achieve our goals. And we have to do statistical analysis on this data. So we have to think about, well, what statistical libraries can we use? On the free and open source side, you have the most popular one, which is R. There are many other products that are either libraries or standalone statistical products, and they come in both free, open source, and the commercial flavors of that. The commercial stuff could get a little bit more expensive, but in all, you're looking for the one that is most popular, most supported, is what I mean by that, and is sort of easy to implement with what you're doing. I just wanted to point out that a lot of these statistical libraries have to be implemented in some way so that they could get from your desktop or web or mobile app to the database. And typically here's your statistical analysis being done, and we have to kind of have your application reach out to a web service which will somehow invoke this or return this statistical analysis which retrieves data from the database. I haven't done years of analysis of the different types of methodologies, but I have noticed that Microsoft came up with a very significantly streamlined methodology of getting your information. They put R directly into the SQL Server. So if you want to put your R script, you can make that a stored procedure in your SQL Server with your SQL code. And if you wanted, I'm not saying you wouldn't use a web service in the middle or not, but you certainly could directly ask for a prediction out of the SQL Server, and it could be returned directly back. That's in terms of coding these days, that just makes things a little more simple. This is a very high level and certainly not an all-inclusive overview of of this universe, but I just wanted to point out one example for you to give a little bit of insight, because maybe you're seeing some of these names of these products and these tools that are floating around and you're not 100% sure how they fit together, and hopefully this very brief explanation gave a little bit of insight into how they might work together. So let's review a couple product concerns that we might want to keep in mind. So here we have a graph of data that is not linear. You might recall that previously we discussed, how far somebody walks and their age. And that wouldn't be a straight line. Here's an example of something that's more looking exponential maybe, that is also not a straight line. It's a curved line, so it's not linear. What does that mean? That means that this type of information would not be predicted well because there would be so many outliers around a straight line. If I were to try to draw a straight line through that, it wouldn't provide a great prediction. The data is not very normally distributed around that straight line, and it would not be a very good predictor. So if the data is not linear, that's going to cause an issue. So that's one concern. And what do we do when the data is not linear? Again, that's where we kind of have to fall back on charting and graphing a little bit more so that we can see that, hey, there is a relationship here. It might not be exactly the linear type that the insights can automatically produce for us, but hey, we got something here, and we could kind of use that in any way we wish, and this graph would, clearly be automatically generated for the user. Then we get into the fact that, well, what if you don't have enough data for the findings or the correlations or the insights, whatever synonym you want to use, to not be by chance? You have to have a significant population, and you might have noticed on the slide when you asked to see the details about the prediction, it kind of came up and said, well, this is or is not by chance. So again, when you don't have a lot of data, it's going to be hard for the insights to do much. So again, that's another case where you fall back on the charting and graphs uh, to find if there is really any correlation. And that's a little bit of a manual process, but again, that's a product concern. The main product concern is that the product is very broad. Again, we use the term Swiss Army knife. So this creates additional challenge for the marketing department to bring something clear and concise to a client. So targeting in the marketing area is going to be a concern. And another concern is when we start sharing this with folks to get feedback, even with the best NDAs, it's possible that somebody could take this concept and get more traction in the market before we do if they have more resources than us. So that's another one of our top product concerns. Anyway, I hope this video was able to clarify more than it confused. And I'm always available to ask questions if you need further clarification. One thing, I don't want to go off on a tangent at this point and revisit anything, but I did review a lot of products and where they fit in on a previous slide. I think it was back a slide or two. Let me see if I could find it really quick. Not that slide. Not that slide. This slide. So in this slide, we started talking about the database and the SQL editors and the statistic libraries. And I also wanted to point out there's a lot of confusion surrounding some of the products that are in the cloud that are basically, I'd put in the category of workbenches. When you have the software as a service and they're putting out together as a package or a big workbench for you your database and your statistical tools like R and other things that are very easy to implement because they're all out there, are all pre-installed, all already configured and working together. And this universe is basically the same thing that you typically see here as separate products, but they give it a name, which is kind of confusing to their workbenches. And you'll see that, almost every company, whether it be Amazon or whether it be Microsoft or, Google even has some of these things clumped together into workbenches, and they give it names, and it becomes confusing. But at the same token, these workbenches make it easy to get started and easier to implement with keeping everything in the same area. I just wanted to point out that these workbenches are out there, and the majority of these workbenches are geared towards a hands-on type of approach where what they're trying to do is try a whole bunch of different tools that are in this toolbox to get more and more and more accurate in their predictions. And that is a very good way to go if that's what your goal is. In our case, we're willing to accept that there is a give and take by automating it and not having as much of a hands-on approach. And that's sort of the direction that we've chosen. So these toolboxes in the cloud, they're wonderful. You hear so many things about them, but I hope in the end that all this discussion surrounding the toolboxes, some of these products that you're seeing, some of the types of machine learning and the amazing things that they can do, that you can now put into context. And the goal with this was so that everybody would have more clarity and less confusion surrounding who we are, what applies to us, and what does not. And I'll be with you in the future talking about this stuff. So Reach out to me if you have any more questions. Thank you.